Thank you for joining NVIDIA and GTRI this morning or afternoon, depending on where you are in the country, to learn a little bit more about the NVIDIA Grid GPU enablement card. My name is Craig Jeske. I'm a solution specialist with GTRI. In the room here presenting for you today, we also have Luke Wignall, DJ Eshelman, and Eric Puccio. And I'll let Luke introduce himself and hand it over. One reminder, we are recording this, and the link will be sent out after the event.
Thank you very much, Craig. So again, my name is Luke Wignall. I'm a senior solution architect with NVIDIA, and we're just going to essentially review at a sort of medium tech level, sort of an overview of the Grid product. And DJ and Eric will be in the background answering any of your questions that you want to send in via chat. So go ahead and text those in, and they will do their best to keep those answered. And then at the end, we're going to have a Q&A session. So there's an opportunity then as well to get questions answered. Let's get started. Let's start with the basics. GPU. What is a GPU, and why are we having this conversation in the first place? CPUs, of course, are the thing that we rely on most and consider most when we're developing or building servers and hosting solutions. But the problem is CPUs are serialized. They are optimized to essentially take a question and provide an answer, then take the next question. GPUs, on the other hand, are massively parallel. They have to flood the screen with and answer essentially all those pixels with what they're supposed to show, and do it fast enough and refresh quickly enough that from our eyes we see a great visual experience. So two very, very different creatures. Making this worse in the VDI world is CPUs are essentially being asked to do everything. So we're not only asking them to manage and run the host, but we're also asking them to then be the vCPUs for all the guests. They have to manage networking and storage and other resources. And then at the very end of that process, we ask them to be GPUs, something they're inherently not very good at, so already tired. The end result is, if you've spent any real time at VDI, you know that adoption rates have historically not been great, and users are generally not that excited. I tend to use the phrase meh is the thing that kills these projects. It's not that they don't work, they just aren't as exciting as what end users expect. So at NVIDIA, we're all about GPU. And here's a good quote that was just recently out talking about just how far we're taking this. NVIDIA is far more than just a GPU designer. It is actually at the leading edge of computing technology, inventing new ways to solve all sorts of human problems. The company participates in almost every realm of the human experience. And we are, at NVIDIA, very, very committed to changing the end user experience. It started with PC gaming in the 90s, where we felt that people wanted to be able to play these incredible games in the privacy of their home, be able to take these games home with them. We then moved to professional graphics, where we knew that professionals working in offices, working with, whether it be CAD drawings or what have you, would want a wonderful visual experience as well, in some cases necessary for their job. And then we went to tablets and smaller devices, and we sort of brought that all together, and we'll talk more about how Grid brings that into the data center. Just as an example of how far we take this, this is a new product that we just released, the JETSON TK1. I don't know if from just a visual cue, you'll notice from the connections on the side of this card that it's roughly the size of, well, a Raspberry Pi, if you're familiar with one. And I use the analogy that the JETSON would be a Raspberry Pi if Raspberry Pi were a supercomputer. This, with its 192 CUDA cores, is quite capable of handling massive quantities of data, and is in fact the engine behind the 3D rendering required on the fly for self-driving cars, which you can see in the three little shapes above the card, an example of how that card on the fly is identifying objects in a three-dimensional environment, identifying those and entering that as obstacles to avoid or a road to follow or what have you. So that's just an example of how far NVIDIA takes GPU technology. Talk a little bit about our ecosystem, the brands that in some cases you should be very familiar with, I hope, and in other cases maybe this is new. So GPU GeForce is where it all started. The GeForce line is our gaming line, not that it isn't also used in a lot of home situations and smaller environments to handle, thanks to its higher clock speeds, some great visual graphics. but really that's that big footprint where we got started. That ultimately morphed into Quadro, and the Quadro is the professional graphics line. I'll touch a little bit more on that on another slide, but essentially the vast majority of the market of people using graphics today in a work environment are using Quadro cards. Tesla is a line that maybe not everybody's familiar with. Tesla is our non-graphical, so there's no output port on the side of the card. Let me actually take a step back. If you've ever looked at graphics, you know that graphics under all the skins and the sort of the beauty of it is a wireframe made up of triangles. So essentially graphics are, in its simplest sort of definition, a massive geometry problem. So GPUs are very, very good at doing high-speed math. Again, massively parallel, right? So you can throw a ton of data at it, ask it to do math against that, and it can produce very, very quick results. As a result, currently, 10 of the top 10 supercomputers in the world leverage our GPUs as part of their processing power. So Tesla is that high-performance computing line where we take the power of the GPU, and instead of making it graphical, we use it for high-performance computing. Tegra in the middle, that's our mobile line. That's our smallest chips, and something that the JETSON that I showed before is related to. That's where you know, your phones, your handhelds, your tablets, and as well as now infotainment centers in cars. If you happen to drive an Audi, for example, some of those amazing dashboard displays now are driven by our Tegra. If you're really lucky and you're driving a Lamborghini, the entire dashboard now is something that we're able to give you the opportunity to design whatever dashboard you want for your car. And that's really the future of where we're going, is visualization in just about everything around us. And then grid, which is really what we're here to talk to today. And that's taking everything I just talked about essentially and transporting it into the cloud and enabling, instead of being beholden to a physical PC with one of our cards in it, now instead we're putting those GPUs into the data centers where they are then shared out to the cloud, and now you're able to get all the benefits of that GPU visually on essentially anything. And no longer are you limited to a high-end card and a high-end desktop, you know, locked to a desk. You can now take that and go mobile. So let's talk a little bit about why this is so important, though, especially on the professional side, because really on the data center, as we talk about grid, the real advantage here is the ability to take engineering apps, architectural apps, healthcare, you name it, oil and gas, all these different markets can take advantage of this in a way we could never do it before. 18 months ago, before we put grid together, along with Citrix and VMware and others, there was no way, you just simply avoided those high-end 3D workstations when you were looking at VDI, because it just wasn't possible. The experience wasn't acceptable, and let's talk about acceptability. Without GPU, on the left, you'll notice the image is two-dimensional and flat. It certainly still conveys all the parts and pieces. In theory, you could look at that and create an object out of that or what have you. But if you look at the right, once you add GPU, suddenly you have the ability to understand, is it smooth? Is it shiny? Is it made apparently out of metal? You know, there's color involved. You put all that together with shading and all the nuances, and suddenly you have something that's much more powerful to present, to understand, to work with. And so it is a dramatic difference with GPU. On the left, I could probably say that if my project SLA said I need to be able to present a drawing in an app, let's say Revit, AutoCAD, you name it, I'm presenting that drawing. I'm successful. But is that really what end users expect and want? No. Take this one step further and we start talking about some of the power. This is an example of SolidWorks, and admittedly this is a recording, but it is a recording of a real live environment where we took Zen Desktop and used grid on the right to accelerate and provide GPU. On the left, we're back to where it was prior to grid, and obviously just an untenable, no end user is going to be happy with that experience. On the right, it's fully rotational, it's smooth, it's a good experience. We've got some other examples here as well that I'll show you in a bit, but why is this so important on the professional graphics side? 82% And really the number is much higher because we don't operate as extensively in the entry-level professional graphics market as we do in the high end. So if you take off that bottommost slice, the number is much higher into the 90s in terms of market share, what have you, in terms of workstations using our cards for professional graphics. We are the de facto standard. And there's a reason, and I almost always get chuckles when I do this presentation in front of audiences because I comment that maybe you've noticed that our driver is humongous. And it's hard to call it a driver when it's just this massive piece of software. Why is that? It's because if you are, say, the last slide, SolidWorks, you, instead of having to write that code yourself in order to handle visualization, display, you name it, you can instead just lean on our driver, our application. And so as a result, you're saved that architectural and design and development cycles, and you're working against a known, trusted standard. And so this is why where our driver is installed becomes so important. Certain apps simply won't install. Certain apps will run sort of handicapped at a reduced functionality level without our driver because they don't have that app, that stack to rely on. So an incredibly important factor. So just at a glance then, what are we doing with Grid? So we're taking that Quadro-equipped high-end workstation and we are taking essentially virtualizing that GPU, sticking it into a data center in the center, running that on top of one of our known hypervisor stacks. In this case, VMware, Citrix, and Microsoft are listed, and those, of course, are the primary players. And then from there, really any app, regardless of industry, as you can see from the list, can be presented to essentially any device, and you can now take that architectural drawing out in the field, look at it on an iPad. I mean, you're not going to obviously interact with the drawing at a detailed level, designing and creating content on that iPad, but you don't have to print anything out. You can go out in the field and compare the two and make adjustments, and that's just something that wasn't possible. And I want to really stress here that Grid in itself is really nothing new. It's essentially the end result of a bunch of tried and true parts that were assembled and finally sorted out in a way that we could, in fact, share out GPU. But the hypervisors aren't new, the GPUs aren't new, the architecture is not really new, it's just the ability to share it that's new. So really something very exciting that was the process of coming together from a lot of different partners. Let's talk about that delivery mechanism then. So how are we delivering those GPUs? I'm starting off with VMware because essentially we're waiting for them to release something called VGPU that they announced earlier this year at our GTC conference. If you're interested in graphics and in GPUs and how this all interacts, maybe just from Grid or from the larger GPU side of things, I strongly recommend that you take a look at our conference. It's a wonderful knowledge sharing environment. Anyways, this year at GTC, VMware announced that they were going to respond with VGPU, but I will comment on that on the next slide with Citrix. So on the left, dedicated GPU, or VDGA as we call it, is the direct pass-through of a GPU through to a virtual machine. So looking at the drawing, you'll notice the GPU punches through the hypervisor, and the virtual machine has, as I say, the important thing in these drawings is where is the green box. So the green box is our driver. Our driver is installed on the virtual machine, meaning that that guest can see the GPU, our driver is able to be installed, and any app then installed on that guest has the full power of our driver and full access to that GPU. It is, however, pinned to that GPU or to that guest, so things like motion and other advantages to hypervisors are not possible because there's essentially a physical connection, so to speak. On the right, shared GPU, VSGA as we call it. And something to note here is no green box in the guests. It says VMware Graphics Adapter, which is their SVGA, just to make this as confusing as humanly possible, is their software adapter. So in this case, with VMware, this is a shared model where we're getting density, a lot more guests getting to leverage the GPU. However, the driver now sits in the hypervisor and is shimmed or intercepted and handed back to the virtual machines where only the VMware software adapter is living, and as a result is not presenting our driver, and any app installed then is either going to be hamstrung or operating at a reduced capacity. And when I say that, I want to talk about two specifics, the APIs. So OpenGL 2.1 or DirectX 9 are the best you can get out of VSGA currently. Important because if your app requires some higher, newer version of OpenGL or DirectX, then you're going to have an issue. I think it's easy to dismiss VSGA then as maybe too old or too limited, and I would strongly disagree and offer this as a true and legitimate solution, because the vast majority of apps at this point, unless they are extremely cutting edge or you are staying very, very current on versions, may in fact leverage OpenGL 2.1 and DirectX 9 and operate fine. In other cases, the reduced capacity or functionality of that particular app, take AutoCAD for example, in educational settings we've had VSGA be a good solution because at the reduced functionality level, that's still sufficient for first-year architecture students, as an example. They don't need the full functionality yet, and you can have greater density then and offer them BYOD so they can bring whatever they want and use lab time from wherever they are without having to commit expensive machinery and 24/7 lab monitoring and so forth. So that's been a great solution so far. So let's talk a little bit about what Citrix has done differently and really drove all this, and now VMware is responding. Our understanding is that we're going to see an answer from them later this year as a sort of tech preview, and then potentially something for full release at the beginning of next year. Of course, it's a crystal ball, so we'll have to wait and see how things go. VGPU. So I've essentially inserted that in the center, although I've flopped VSGA and pass-through here. Notice now that the green boxes are in the guests. So again, there's the green box. Instead of a driver inside the hypervisor, what you see is a GPU manager. And all that's doing is essentially sharing out and time slicing the GPUs, essentially no differently than we do CPUs with a hypervisor, except it allows the guest and our driver to communicate directly back to those slices of the GPU. So essentially, it's the power and benefit of pass-through with all the flexibility and advantages of shared. Exactly what somebody would want out of this. You now can get greater density with more horsepower thanks to VGPU. In terms of architecting a solution, what sort of densities can I get? Here is, call this a simple cheat sheet. This is a starting point. I would strongly recommend that test your apps stacked the way you install them and the ways that you install them and the size of your objects or your projects. All of that can directly impact performance and adjust these numbers, as well as storage, as well as networking. This is still VDI and all the parts and pieces that are required to make a good VDI solution are necessary. Now you can add GPU and make it a great solution. You'll notice really the limitation here, and I'll talk a little bit more about cards in a bit, the specific cards in a bit, but the Grid K2 is the more powerful card, but it only has 2 GPUs on it. Essentially, they're K5000s, 2 of them bolted together per K2. So if I have a standard 2U server, it's a certified server, and it supports our cards, I can generally fit 2 of those cards in on average. So 2 K2s would give me a total of 4 GPUs. I then, thanks to VGPU, can slice that up into any one of the profiles that you see in the second column. Take a K240Q, for example. What that's really slicing up is frame buffer, so the graphics memory, which in this case is 1 gig on that profile. There are 4 gigs of frame buffer per GPU. You can only slice those up so many times. You can only pick one profile per GPU. So on a K2 card with 2 GPUs, I could pick, say, a K240Q for one of the GPUs, and I can pick a K260 as an example for the second GPU, but I can't blend them on any one of the GPUs. Hopefully that makes sense. You'll also see a maximum resolution and the resulting, maximum displays and then max resolution. And again, any change to these is going to change your density equation. So test, test, test. We'll move on and talk a little bit more about how this breaks down. In fact, you'll notice, I'm going to jump back real quick, the use case at the end, designer power user, knowledge workers, power users, what does that relate to? Notice the stack on the left. We really see designers as those people that create content, they render content. They are our most extreme 3D graphics user. Power users may be creating content as well, but typically not with as intense of an application. Or they may just be viewing and interacting with those drawings. Knowledge workers might be viewing, but generally are using less intense 3D apps, and we'll talk a little bit more about the apps that we have listed here. And then task workers, it's interesting, but as more and more task workers, and here we show as just a character the call center worker, as more and more of their apps are web delivered, we're seeing more and more HTML5, we're seeing more interactive graphics, really anything on this list. We're only moving towards a better graphical experience, not a worse one, right? None of us are looking for a boring two-dimensional or text-based experience. We're looking for something that's eye-appealing. And as a result, these needs are only increasing. We have a question that just popped up. Okay, yeah, this is a good question. So somebody just asked a question about streaming media, YouTube videos, Flash, that sort of thing. Yes, as a matter of fact, it will. There's two ways to look at this. Let's start then at the bottom of the stack. Task workers, knowledge workers are people that generally use minimal 3D, but they use graphics. We have Office 2013 on here, for example. It is DirectX, but it is graphics. It's leveraging graphics acceleration. You can actually disable that under options or under tools. If you look at any of the modern, and we have some of these in a future slide, any of the modern PowerPoint animations alone demand a tremendous amount of GPU. But we're also seeing graphing and other things in Excel, for example. People are embedding Flash media, YouTube videos, and so forth in Word docs. There's really no way to get away from graphics. So to the person that posted that question, yes. I use the analogy that with standard VDI, you can count on a bad Kung Fu movie experience with streaming videos. Add GPU, distribute that load, have it accelerate that experience, and you now have something that's actually usable and an enjoyable experience. Notice at the must-have side, at the upper part of this stack, though, you have PTC Creo, SolidWorks, Autodesk, apps like Revit that actually use rendering and OpenCL as well. You've got Photoshop. The list just goes on. All of these apps are now moving more and more towards more and more graphics, and now you can do that in the cloud. So let's talk about the cards. Again, the K2 is the quote-unquote better card. It is two high-end K GPUs, essentially K5000s, bolted together on a card. I think it's important to reference that both cards are the same size. So because the K1 has the equivalent of Quadro K600s, we can actually fit 4 GPUs on that card, whereas the K2 can only support 2 of the higher end. Notice the number of CUDA cores. Again, if you compare this to a standard CPU, this is a very, very different creature. Massive amounts of cores designed to do a tremendous amount of parallel processing. And then, as I said before, 4 gigs of frame buffer per GPU, albeit the faster DDR5 memory on the K2 card. And then notice power. 225 watts per K2. These are full-length, double-wide PCIe cards. They require power. You will end up with power cables running from your power supplies to these cards. They won't run otherwise. And a pair of 750-watt redundant power supplies in the back of the server are simply not going to run the server and these cards. We hammer this because you must use a certified platform to support our cards. They're passive cards. They have no cooling of their own. We do have an active K2 version that's rolling out now for chassis that have a difficult time keeping our cards cool. and we're seeing more and more certifications around that. But the primary two cards are passive and do require servers that can support the appropriate amount of airflow and appropriate amount of power. So here's an example again of, and this goes back to the person who asked the question about just, Flash and things that maybe aren't the exciting 3D application, but quite frankly are, in some cases, more important to the largest quantity of end users, right? So HTML5, web-delivered content.
I do want to add one caveat, because we're doing this over the WebEx protocol. It's not as good. Do the demo. If you want to see more, there is a free 24-hour demo on the NVIDIA site. We'll discuss a little more at the end. But take things over the WebEx with a grain of salt. Know that it is 50 to 100 times better with the grid card, even over a WAN environment. We can show you where to go demo that.
True. Thanks, Greg. And that's an important thing to note. There are so many factors here, and I do absolutely hope that you'll download this session and look at it live so that you can, or local, so that you can see these things. But more importantly, do go to our Tri-Grid site, and as Craig said, we'll cover that, and see it for yourself. Give it a test drive. That's the whole point of the Tri-Grid, is truly to test drive this and see it for yourself. It does work. It's making a tremendous difference, and we expect you to challenge that. Again, here's just another example. Photoshop. These are the sort of the commonly asked app questions, but really, if you go to Tri-Grid, you have an opportunity to upload your own app, install it. Obviously, there's license issues and so forth in some cases, but eval software, if you've got access to it, use something like a Dropbox or something similar to upload some data, knowing that when you log off and you close that session, that desktop's going to be erased, deleted, killed, and you won't have to worry about that data living anywhere. Obviously, don't put anything up, though, you'd be concerned about. Google Earth. So, interesting little anecdote from several recent VDI projects. The single most commonly overlooked app, although this is not an example of the specific version, is when you do a VDI project, you typically do a full site assessment, look at your users, put them into buckets based on apps or use or whatever use case, and you generally start with your least challenging use case to roll out so that you can optimize and test and confirm that the rest of your environment is optimized. The problem is the single most overlooked app is Google Earth delivered through Chrome, so not installed locally, but actually rendering it through the Chrome browser. You do your site assessment, and all you see is Chrome installed everywhere, and you think, oh, they're an alternate browser user, and you move on thinking this user doesn't have, or these users don't have a ton of GPU need, and then have a tremendous quantity of complaints saying that they're having a miserable experience because Google Earth delivered through Chrome still demands DirectX or OpenGL, and it will not perform well unless it sees GPU. PowerPoint, we mentioned this before. You look at some of the, I jumped past it. You look at some of the animations available, and you've got some unbelievable fades that are currently, transitions, you name it, that are currently possible. That is an example of what used to be the safe area, so to speak, for applications because they didn't use GPU, no longer true. So the NVIDIA Grid ecosystem, like I said, none of this is new. If you look at this list, we took existing GPUs, optimized them for cloud use. We work closely with the top virtualization platforms, and we are engaged with the key OEMs that are going to support our cards. So again, nothing here is, untested, new. It's just how we all put it together that really is new. And I made the point about certified. The link at the bottom, by grid. If you go to our website, /bygrid, you will see the current list. Up here we've got, essentially we chose two of the more common platforms from each of these primary OEMs, just to give you a sense of sort of the workhorse servers that now support our cards, but definitely go to BuyGrid to see which platforms are certified to ensure that you are working with the right server. Again, it's a tremendous amount of heat. If you don't have proper cooling, you will easily turn your server into an easy bake oven, and no guarantees if you don't have a fire extinguisher nearby. All fun aside, you really stand some risk of some damage if you don't have these things properly cooled and properly powered, or they won't function. A little bit about NVIDIA. We haven't really talked about us and who we are. The company was founded in 1993. We've been around a long time. JETSON, our co-founder and is still our CEO, still extremely active, extremely passionate about GPUs and what the power they have and what they can do. He is an absolute force of nature when it comes to ensuring that end users have an incredible experience thanks to our products. We invented the GPU actually rolled in '99. I mean, obviously invented previous to that, but that's since that day we've just shipped an amazing quantity of these things and produced a tremendous amount of revenue. Bring all this up to just demonstrate that NVIDIA is really a leading force in graphics and GPU. I think the most exciting one here as an NVIDIA employee is the better than 7,000 patents. If you ever have the opportunity to visit our campus and you're eating lunch in our cafeteria, there is just this continual stream of announcements of people that are patenting new technologies. NVIDIA is very proud to be on the bleeding edge of thinking about what we can do more in terms of technology. Here are some resources. The one I'm most excited about is the fourth one down, our forums, something that I am actively moderating along with several of my other fellow solution architects. Quite frankly, most of even our applied engineering crew is paying attention as well. So it's one of those rare times where we have a new resource and you have the ability to drop in a question and actually get backline engineers' direct attention. Challenge you to challenge us. It's also a great community to provide feedback, benchmarks, what's worked, and help others through this process as well. The newsletter is something that I think a lot of us dismiss because it's newsletters, right? Spam. In our case, it's only monthly, and it does a deep dive into all the various parts and pieces of the things that we're doing. So again, it's something that I think is a tremendous resource and worth signing up for. Last but not least, our YouTube channel, which of course we accelerate in the VDI environment. A tremendous amount of information there as well. I hope we've covered enough to at least get you excited about this technology. It's good to be able to present something like this with GTRI, who's really been pushing quite hard to get this out in front of customers and build trials and pilots and expose their challenging apps to this answer that previously wasn't possible. Let's dive into some questions.
Cool. All right. So thank you very much, Luke. This is Eric Puccio, and I've fielded a few questions from chat and Q&A, so I'll throw them out there for the room. And I'm not going to read them verbatim, but kind of read off exactly what the point is here. So first question was specific to grid cards required in every host if you have an environment, and the environment's not necessarily a XenApp or a VDI type environment. But the question was, can you move workloads around intelligently to leverage a grid card if it's only in a certain host and not in other hosts? And
it's a good question. So if you recall back to the slide showing the delivery mechanisms, if you're doing pass-through, you're essentially pinning that physical GPU to that guest. So there are PCIe mappings going on that would need to be recreated. So things like HA, motion, and so forth are not possible. Currently, under Citrix, VGPU, there is still that PCIe mapping going on because they're directly communicating back to those virtual profiles, those slices, if you will, of the GPU, and so motion's not possible there either. However, as long as you had two hosts, both equipped with the same hardware, including the GPUs, it's a minorly manual process to shut down, migrate, and bring back up, especially with shared storage, of course, remap to the new PCIe addresses and have that particular guest back up and running very, very quickly. So certainly some limitations in terms of virtualization. I don't believe that it's a showstopper. It's the sort of thing that most of these use cases, these are high-end desktops that you're bringing in the cloud anyways. And so you still have that tremendous flexibility that you've gained by virtualizing.
So what about profiles? What about managing a specific profile or setting up something where that user logs in, and then based on their login, they have access to applications or desktops that are either GPU-enabled or not GPU-enabled?
Pointing to DJ. So from a Citrix perspective, let's talk a little bit about profile management. So I've got some users. I've assigned them a K240Q. I want to migrate them maybe to a different profile. Talk about some of the tools to manage that and support that.
Okay, if we're talking about the actual users' files, those kind of profiles, is that the?
No. Someone logs in and there's say it's a XenApp environment or an environment where there's hosted applications. They log in and that user is going to have access to certain applications that are GPU enabled and certain applications that don't have a GPU assigned or is not GPU enabled. Based on that user's login credentials, is there an ability to manage or control which users have access to a GPU enabled server or host and which users do not?
Absolutely, and that's usually done by the actual assignment of those resources, which can be grouped in a variety of different ways, directly per user. The preferred method would be to actually map those in Active Directory groups, making them more easy to manage from multiple different tools. And so that's the way that would be done, basically.
So from like a real world example, I've got an end user that was a viewer of whatever high-end app. They've been promoted. Now they're going to be actually creating content.
Right.
I move them from the Active Directory viewer group to the creator group or whatever we want to call them. And as a result, Citrix, behind the scenes or whichever platform, simply then assigns them this new desktop, and with that new desktop, they get the profile, and they get better graphics.
Yep,
exactly.
One of the things I wanted to toss in there, sorry, DJ, I'll jump back in a second, just because this is something that rarely comes up in these sorts of discussions, but comes up later as we start talking about density math. How many guests can I get on a host? Don't forget that just because you've assigned all the GPUs and you've essentially run out of GPUs, but you have additional resources on that box, you can still put other guests on there that do not use GPU. Those could be desktops, those could be servers, whatever the workload. Point is, consider that you can have multiple profiles or no profile guests on a host.
That's correct. In fact, that's something that we actively recommend, mostly because, as you noted in the previous slides, there are a limitation of the number of pass-through GPU and virtualized GPU profiles that can be existing on one grid card. So if you only have one card in your server, well, maybe you don't want just 8 users on that entire server. So you want to be able to utilize those resources appropriately. Of course, Citrix recommends that only the actual resource CPUs and that sort of thing are being used there, so you'd only have your XenApp or Zen desktop workloads, not your control layer workloads. But that is important as well.
So we have a few other questions. I'm going to run through these. So another question came up. It was specific to a Zen desktop environment with Zen server. It's about VGPU profiles. The person has assigned a VGPU profile with a K1 card that is a 2-to-1 profile. The Q140.
Yeah.
Thank you. The Q140Q. So the question is, it says max number of displays is 2 for that profile. Currently, they have 1 display set up. How do they set up that second display in the VM?
So this is more of a thin client conversation at this point. So, and in fact, let's take a step back and talk a little bit about end nodes. One of the things that we run into, I used the example earlier about an iPad. Somebody's got a drawing, they go out in the field, they carry the drawing with them, so to speak, obviously. They're just connecting back over, call it Citrix receiver or the view agent back to their desktop, and then they look at that drawing. Is that iPad going to give them a great experience? It's not a bad experience, but like I said, it's, I always joke, you're never going to write your doctoral thesis on an iPad. It's just not the platform for doing large-scale work. It is a great platform for going out in the field and looking at a piece of a drawing and going, wow, I really need to draw that differently, or that's not what I thought I was drawing against. And as a result, expect that iPad with its limited capabilities to provide a decent but not amazing experience necessarily as they would expect from their desk when they sit down with a full keyboard, mouse, the whole 9 yards. So how do we make that experience better? That gets back to the thin client. So if the thin client has its own capabilities, an ability to either accelerate HDX or PC over IP, if it has sufficient processing power of its own, then it is able to encode and decode and handle that communication better than, say, that iPad would. And so that experience is a better experience. You can also then get an end client, a thin client, that has multiple display ports on the back, allowing you to support, depending on the profile, 2, 4, whatever profile or monitors.
So setting up that second display, is it something a function of the hypervisor? Is it something a function of the guest OS, the Win7 guest OS? Or is it a combination of the grid?
Combination, essentially all those pieces have to be able to communicate, and the end node has to be able to support.
Okay, for the person that asked that question, we'll note that and send you some detail of how to go and set that up or assist you with that via GTRI. So we have your name and information. Cool. So talking through that. A couple other questions. I think some of the panelists actually responded. From the question came up around blades, specific to a Cisco stack, but let's talk about it openly. And I can just answer this very quickly. Currently, as you saw on the slide deck, the grid cards are sizable. They're a full-length or full-height PCIe slot, double-wide card, leveraging multiple GPUs, either 2 on a K2 or 4 on a K1. We are working diligently with major OEM manufacturers, Cisco included, to include a different form factor to work in blades. So currently the only blade form factor that's supported today is from HP, and it's the WS460C workstation blade. But there will be, if you keep an eye on this and watch very closely, there will be support for blades coming up in the future, just to be determined how soon in the future. But keep an eye on it. I would say probably our newsletter might be a great resource for a monthly single email to have regular updates when that support will come, or keep an eye on our website, nvidia.com/VDI.
And to reiterate, the size of these cards, right? The existing 2 cards being full-length, double-wide, full-height cards, if you're in that HP blade, essentially what you're buying is the blade server itself, then a graphics expansion blade that sits adjacent to it, and those 2 communicate. So essentially, for each one of these, you're going to occupy 2 slots in your blade chassis.
Cool. So,
I have one more add. This is Craig at GTRI. If you have any desire to demo, reach out to GTRI or NVIDIA, and we will work with you and your server OEM of choice to get the hardware on site to test this out and see if it makes sense in your environment.
Let me actually, I think this is an important note. So we talked about TriGrid before, our test drive at the NVIDIA site. Great for, simple tests, proof it works, an opportunity to experiment and, maybe identify that it is worth considering before you, engage management or whoever. Where GTRI can make a bigger difference than we can with that test drive is they can actually help you build your trial on-site with your hardware, with your apps, and actually demo the real environment that you're going to be presenting to end users. That's not something that's possible with our test drive. Our test drive is meant to be a simple taste of what's possible. I think that's important to note. A question that popped up is Apex cards, TerraDT Apex cards for VMware PC over IP environments. And do we work in conjunction with them? Yes. Obviously, we're both occupying slots. So a typical format would be take a 2U server, you'd have one of our cards in one slot, you'd have an Apex in the other slot to do CPU offloading. This has worked very, very well in customer environments where CPU congestion was the issue, and the Apex card was able to offset that. Meanwhile, our GPU is handling graphics acceleration. So a wonderful pairing, absolutely.
So another question came up. That was one I was going to ask, actually, so thanks for reading that. Another question came up specific to CUDA programming, and a little bit more about CUDA from a programming perspective with a GPU or a non-visual GPU, but also, could CUDA be leveraged with a grid card, and if so, how? It
is possible. VGPU currently doesn't support that, but on pass-through, So if you're dedicating that GPU, pinning it to a guest, that guest then could in fact run OpenCL, CUDA, and handle some HPC work. Obviously, this is not a replacement for a Tesla, but there are apps that absolutely leverage and do rendering using CUDA, and you can use these cards to do that as well. Absolutely.
Excellent. What about in a XenApp environment? Is there any ability to go and leverage VGPU with a XenApp host? sharing of a GPU to one GPU to multiple XenApp hosts.
So my chuckle is because depending on who you ask, in theory, you would be able to do what, and I should probably preface and say, do what Citrix says is unsupported. NVIDIA also says it's unsupported because Citrix says it's unsupported. In theory, you would be able to take, say, a K1 with 4 GPUs and run VGPU and hand out slices of those GPUs and run an amazing quantity of XenApp servers on that particular host. Obviously, I think right out of the gate, you start thinking, well, it's an awful lot of resources, awful lot of eggs in one basket sort of thing. And that's true, but it gives you a sense of what's possible. And the way that we traditionally handle XenApp in the past was on bare metal. The problem is you're installing an OS on bare metal. You have none of the advantages of a hypervisor. So things like HA and so forth have to be handled in sort of an old school way. On the other hand, if I install a hypervisor, it doesn't matter which one, I run XenApp on top of that, then use pass-through and hand, say, the K2, so one of those K5000 equivalent GPUs through, and allow XenApp to share that very powerful GPU out, you can get tremendous density and an incredible experience on the app that's being shared. So a very, very good solution. And again, that's all you've done is leverage one of the GPUs. So you could still build a second XenApp server on that box, pass through the second GPU on that K2 card, and have 2 XenApp servers running, or use it for a variety of desktops, whatever.
So another question came up. If you had, say, a grid K2 card and a single grid K2 card and a host, could one of those GPUs be leveraging a VGPU profile and the other one do a pass-through?
Absolutely. So the only limitation is the inability to use multiple profiles. So say, I think I used earlier the K240 and the K260Q profiles. You can't mix those on a single GPU. Not a single card, because a card contains multiple GPUs, but any one of those GPUs has to have a profile assigned to it. And again, that's because we're slicing a frame buffer, and those slices have to be equal. We currently cannot oversubscribe frame buffer. We need that frame buffer to provide that massively parallel answer to flood all those pixels and create that visual image, and to do it very, very rapidly. And we aren't currently in a position to be able to share that out and essentially oversubscribe it. And I think that would be the biggest hurdle in multiple profiles on a single GPU. So how do I architect this? You could potentially take a server, put 2 K2s in it, 4 GPUs, pick a profile for one of the GPUs, pick another profile for say the second GPU, do a pass-through for the third, and maybe take the fourth and assign it back to one of the earlier 2 profiles, or pick a third profile. So tremendous amounts of flexibility, and as we said before, still have, if I have room in terms of CPU and RAM on the host, still have guests that don't use any GPU.
So you mentioned, another question came up, you mentioned earlier about VMware and the ability to go in the future to provide VGPU like they do with Citrix and Zen Server. That said, could you run a XenApp workload on a VMware ESXi host? As well, could you run a Zen desktop workload on an ESXi host and then leverage GPU, and how would that look?
So we call that a hybrid environment when we blend, one vendor with another vendor's, say, VDI or streamed app streaming solution. So take maybe one of the most common use cases, which is XenApp on top of ESXi. You use pass-through. It's no different than if it were VMware on VMware or Citrix on Citrix, but we're going to do a pass-through to that guest. We're going to pin that GPU to the guest. That guest is going to run, Windows Server 2008 or 2012, and we're going to install XenApp and leverage that full GPU with that XenApp guest. If we did Zen Desktop on top of ESXi. The problem currently is that the VGPU itself, that capability, that piece of code, if you will, exists within the hypervisor, so currently only exists in Zen Server. So to get VGPU, you would need a pure Citrix stack. So Citrix Zen Server with Zen Desktop or Zen App on top, and you would have VGPU.
So with that, another question kind of popped up. VGPU versus sharing, like a VSGA model. Can you just repeat the benefits of VGPU over sharing or the differences?
I'm not sure I understood the question.
So VGPU versus a VSGA.
Well, so, and like I said before, VSGA, I think, gets a bad rap because of the API limitations. Again, OpenGL 2.1 and DirectX 9. It's easy to chuckle and say, well, what is that? 2003 probably, XP sort of era. But the reality is the vast majority of apps, and like I said, unless you're staying extremely current on upgrades or leveraging some very serious applications, in general terms, a lot of apps are quite happy operating at that level. And so as a result, VSGA is a great answer. And you get tremendous density out of it. An interesting sidebar on VSGA, the default deployment for Horizon View is with the adapter set to automatic. So you have a choice of hardware, software, or automatic. So it essentially, as the view agent comes up, the guest comes up, it identifies what it has for available GPU resources. Of course, it's a shim model, right? We don't get the driver in the guest view environment unless we're using pass-through. So at that moment, as the software adapter comes up, it's set to automatic. If it's being told that it has VSGA, it automatically leverages the GPU. This is important because it actually uses 50% GPU, 50% CPU, and as a result, still can be motion. So this is one of the cases where I think there's a huge advantage to VSGA because you can motion guests back and forth, even on the servers that don't have GPU, where that automatic setting will automatically switch to software rendering instead of hardware because of the lack of GPU on that particular host. So a tremendously flexible answer.
No other questions?
Oh, we did one. Just a clarification on someone who was asking about the hardware. Let's say, for example, you have some of these cards, and I sent in the chat window for everyone a link for supported servers that support the grid cards. It's important to note that these are new purchased. If you have an existing server like that, you probably want to talk to us or representatives here at Grid just to make sure that you have the correct power and internal structure with that server. As you probably note that many manufacturers use many different boards within their models. It is important that the right power and firmware infrastructure be in place. So if you have these existing servers and you're interested in trying out Grid, either as a trial or just to buy, please go ahead and talk to us just to make sure we are all level set on our expectations with that.
Very good point. I cannot stress enough that they have to be certified platforms with the enablement kits, which generally speaking are power cables, as DJ referenced, some chassis improvements on the inside, sister cards, riser cards, things like that, some additional baffling for airflow, and those two huge power supplies. So, just to give you some reference points, I think the Cisco UCS platform uses a pair of 1,300 watt power supplies in their enablement kit. So definitely not the standard offering. I think we've run the gamut on questions. I appreciate your attendance. I appreciate that everybody stuck through to the dire end, and I hope we've been able to clear some things up and introduce you to Grid today. Thank you very much.
And if anybody needs to contact us, we put some email addresses for contacts in the comments section or in the chat window, or reach out via the email that you received in the invitation, and it will be forwarded over to myself, Eric, Luke, or DJ. Thank you all again for joining us and sticking with us today. Have a great rest of your day.